This is a video for the Chapter 31 lab, which is week 11 of a fall-spring semester, or week 6 during a summer semester. So we'll come up on the procedure. You're going to need to open, print, save the Excel file, and then we're going to want volume 2. Okay, there we go. Waves, lights, much better. Back to the French guy whose name I can't pronounce. I got straight D's in French in 10th grade. I'm not even going to try. We're going to come to the information tab and let you read it. And you may want to pause so you can read the whole thing. I'm going to come off the information tab. And I'm going to turn the experiment on just to watch it go back and forth. So now the light beam is going through the hole, the gap, it's hitting a mirror, it's coming back, and we'll pause it, we'll reset it, and the mirror is 8.65 kilometers away. Notice that your ability to see what is happening here is greatly diminished by the speed. So what we're going to do is we're going to reset it, and we're going to go to slow motion. And we're going to turn it on again. And in slow motion, we can see that beam's cut off. And we're going to see that now we've got a beam. And that beam is going to the eye, and it's coming through and being cut off again. So we're going to have to go and get that beam right there. So that's the beam we're looking at, going to the mountaintop a long ways away and coming back to see the observer. So that's what we're going to be doing. So we'll reset all this, go back to slow motion, and look at our procedure. And it says to start at 2800 revolutions per second. Okay, so I am there. So I'm going to start there, and we'll run the experiment at that speed. We look at the procedure, and it says I'm supposed to measure the length of the ray of light, and record my answer in B. Okay. So I don't have a length of a ray of light yet, so I can't do that yet. And boom, now I have a length of a ray of light. I'm going to pause it. So we'll go just a little bit further. Okay, so now I've got a length of a ray of light. I'm going to take my ruler and I'm going to measure that light. And I know the length from there to there. And I'm going to do a proportional thing. You remember what it was? 6.35, is that what it was? 17.3 round trip, so you're going to divide that by 2, but you probably remember what it was. And that's going to get you the length of that ray, which you're going to put in column A, no, in column B. I'm going to put it in column B. And then you're going to calculate the speed of light. You're not going to calculate the speed of light from that length of the ray. You're going to calculate the speed of light using the revolutions per second and the distance between when it comes in and when it comes out. So that's going to be an interesting calculation for you to figure out. But you're basically figuring out the speed of light based on the revolutions per second, not the length of the ray. Okay, so we're going to do it again, and you have some errors to do too, so isn't that nice? We're going to do it for each of the speeds that are on my table. Okay, so we're going to do it for 3, 30, Now, reset. Go to slow motion. 3,000. 3,000. Okay, there we go. Boom. And now we're going to get a length of the ray coming up here sometime. Okay, now we got a ray. Notice that the returning ray right now is going to be cut off. Boom, it just got cut off. So 3,000 revolutions per second is not the right speed to get the speed of light. What you want to do is have the ray going to the mirror and the ray going to the eye being of the same length. So that's what you're looking for. So this is coming back. Oh, I forgot to pause it. Quick. Now we'll get it this time. Boom, pause it. Notice that that ray was cut off in the apparatus. So measure the length of the current ray and record it on your table after you do some calculations. I'm going to come back to restart, go to slow motion, go to 3200, start. So when we're absolutely right, the length of the ray heading towards the mirror and the length of the ray heading towards the eye will be of the same length, which of course will never happen because we don't have enough significant digits in the apparatus to give us what we want to have. But boom, the length of ray going to the light was just cut off. So we're still going too small. We're going to have to pause this. Pause, measure the length of the ray, do some calculation, and tell me how long it is. Reset, slow motion. That was 32. We're going to 36. 36. Okay, so now we're at 36. And we need the apparatus to give us the length of a ray. And at this speed, the ray gets cut off again, so still not the right one. Going to do a pause. Okay, we're going to do a pause. We're going to measure that length of ray. Do some calculations to get the right number. We're going to go to, after 38 comes 4,000. We're going to go to slow motion, go to 4,000. And we come in and we find what? We have to get a ray first. We don't have it yet. All right, so now we got a ray. Going to pause. We're going to measure the length of that ray, do some calculations, and change it into the number of meters it is. We're going to continue, and we're going to see that when this ray comes back, it's going to get cut off by the apparatus. Boom, it just hit it. So right now the ray hitting the eye is considerably smaller than the ray going to the mirror. That's not the right speed yet. Okay, we're going to increase the speed to 4,300. And need to have a ray, which we don't have yet. And now we have a ray. And I'll wait a little while, pause it. Okay, we'll pause it, measure the length of that ray. We'll continue. Notice that the ray is skipping one of the notches in the apparatus. I don't know if you noticed that or not, but that'll be something you have to take into consideration. Again, the ray is being cut short, so 4300 is not fast enough. So 4350 4350, slow motion. Waiting for a ray. Now we get a ray, that's good. Ray's coming back. We better pause this so we can measure the ray. So measure the length of the ray, do some calculations to figure out how long it is. It still hit and got a little bit close. It's a little bit smaller now than the one heading that way. So it's a little bit, it got there a little bit too late. So still a little bit short on speed. Okay, next one is 4400. Unless we've already done 4400 and I forgot. Slow motion. So this is the experiment that we use to calculate the speed of light to 9 or so significant digits 100 years ago or so. Okay, there's a ray, so we're going to pause to let you measure it. Okay, so there's the ray that you're going to measure, come up with the length of. Okay, it hit just a little bit too early, so we're still not going fast enough, and it's gone before the other edge comes out, so we still have to be rotating a little bit faster than that. Okay, 4450. And if I didn't pause to get the length of that ray, pause the video and get it for yourself. That would be okay too. Slow motion. So it's your job to come up with the equation that's going to be used to for this apparatus to find the speed of light. Okay, so measure the length of that ray. And we'll watch it on the way back, see what we think. Still hitting a little bit early. And is gone, yeah, so we got to go a little bit faster. So we'll reset and go to 4500. And 4500 and 4550 are the last two. So we'll come up and get a ray made. Okay, now we got a ray made. Let it hit the mirror and come back before we pause it. Okay, so the ray is made, and that's the length we're measuring with our ruler. Seems weird to measure it with a ruler, but that's the only choice you have. And it looks like it wasn't blocked going in, but it may have been cut off going back. So someplace between 4450 and 4550 should be close to the right answer. But you want it within 5 significant digits. Isn't that nice? Which you're never going to get on this apparatus because you're going 50 revolutions per second at a time. Okay, this is our last time to do a measurement. And look at array first. Here it comes. And we'll get ready to pause this for a moment after it turns around in the mirror. Okay, so measure the length of that ray. Do some calculation to get it to the right length. And it wasn't cut off going in, but it looks like it might be cutting off going out. Okay, so that's all the data you need to take. Use your awesome 8th grade math skills and figure out what this apparatus is doing, and everything will be fine. That ends the Chapter 31 video. Chapter 31 lab video.